So this question, we have a picture to start. There is a chain with links. It's a number of metal links. It's suspended. And so we see there are these individual links in the chain. The length of the chain can be increased by adding links. So if we added links, the chain would become longer, like so. And so what we could say then, as L increases, D increases. As you could see, that length D will get longer as we make it longer. And so the opposite of that would also be true. As we decreased L, D would decrease. And when D is 0, then L will equal the distance A to B. So those are the things just to study to make sense there. Okay, it can be increased by adding extra links. Experiment was undertaken how D varies with L. So we already know there's an increase. As L increases, D increases. And so it comes as no shock with this graph that that's what we see. As L increases, D increases. So this is a perfect time for us to do an Oizerga on this. So O-Y-X-I-R-G-A. The origin, 0, 0. That's good. Y-axis is distance in meters. X-axis is length in meters. Oh, interesting. The intercept, there is an x-intercept, which we could determine after drawing a best fit line through the data. So something like that. So the x-intercept is at about, let's figure out the scale here. The y-axis, we have 1, 2, 3, 4, 5. So this goes by 0.2. And the x-axis we have, so this is 0.25, and there are 1, 2, 3, 4, 5. So this is by 0.05. 05, 10, 15, 20, 25, 30, 35, 40, 455. So we've got that like so. And the other thing for us to figure out is the error bars. And so we can see that for the vertical, the error bars are going to be plus or minus 0.2 since it's up or down one block. So the x-intercept is going to be at about 0.45. The D equals 0. All right, so then we can read D and L. The slope is delta D over delta L. And so that's going to be have units of meters per meter. So that's just going to be a ratio. It's going to have no units. But it's the rate of change with D with respect to L. So when I decrease L a certain amount, what happens to D? The area is going to be D times L, which will have units of meters times meters, which is meters squared. Don't really have any sense of what that is, but the units would be the same as meters as area. And so draw a best fit line through the data points to the graph. And that we've done. And we do that by planting our hand on the paper and holding our pencil kind of loosely. And it needs to be one smooth mark. It can't be multiples. And we'll do the next part in the next video.